This is a video on how to calculate using Ohm's law, determining current, voltage, and resistance. So let's go ahead and start off with current. A simple DC circuit provides 6.0 volts and has a resistance of 2.7 ohms. What is the current in the circuit? Well, we are looking for current, so we're going to use that formula. Current, I, is equal to voltage divided by resistance. Voltage is 6.0 volts and resistance is 2.7 ohms. So we're going to plug those numbers in. 6.0 volts over 2.7 ohms. After calculating it out using math, we know that the answer is 2.22 repeating. We're going to round to the nearest tenth, and our answer is 2.2 amperes. Amperes is the unit for current. Let's go ahead and take a look at another problem. A simple DC circuit provides 8.0 volts and has a resistance of 3.4 ohms. What is the current in the circuit? Well, again, we're looking for current. So we're going to use this formula. I, or current, is equal to voltage over resistance. Let's see what we have in our formula, in our problem for our formula. We have 8.0 volts. Volts is the units for voltage, and 3.4 ohms, which is the units for resistance. And after calculating those two out, our answer is going to be 2.35 amperes. Now let's round this up to the nearest tenth. 2.4 amperes is our final answer. Let's take a look at one more problem of this type. A simple DC circuit provides 12.0 volts and has a resistance of 8.2 ohms. What is the current in the circuit? Well, we're looking for current. Having this in mind, we're going to use the same formula we did last time. I, which is current, is equal to voltage over resistance. In our problem, we have our volts, which is 12.0 volts, over, now we need our resistance, 8.2 ohms. After calculating out the math, our answer is going to be 1.46 amperes. Now we're going to round this up to the nearest tenth. 1.5 amperes is our answer. Now that we've learned how to calculate for current, let's switch gears and figure out how in the world to calculate for voltage. An ammeter in a simple circuit indicates 3.5 amperes. The circuit has a resistance of 1.9 ohms. What is the voltage in the circuit? Here, we're looking for voltage. Now wait a minute. Our formula, I equals volts over resistance. This is for calculating the current, this doesn't tell us what our voltage is. So we got to rework it to get it to mean voltage is equal to something. So to figure that out, we have to get voltage by itself. Well, currently voltage is not by itself. It has the resistance being divided. So to get it by itself, we have to do the opposite of what resistance is doing. Right now, resistance is being divided. So the opposite of division is multiplication. But what we do to one side of the equation, we have to do to the other. So we have to have multiplication by another r. These two r's cancel out, and we are left with V equals I times R, or voltage equals current times resistance. Now that we have our new formula, we can figure out voltage, because we got voltage by itself. So, using our new formula, let's see what we have in the problem to figure it out. Well, we have our current, which, if you remember from our last problem, A is our unit. So 3.5 amperes is our current, and here's 1.9 ohms for our resistance. So let's plug it into our formula. V is equal to 3.5 amperes multiplied by 1.9 ohms. V is going to be equal to, after we figure out the math, it is 6.65 volts. But we want to round to our nearest tenth here, so it'll be equal to 6.6 volts. And that is our answer. Let's try another one like this. An ammeter in a simple circuit indicates 5.8 amperes. The circuit has a resistance of 2.3 ohms. What is the voltage in the circuit? So here we're looking for voltage. But then again, we have our formula from Ohm's law that says I, which is current, is equal to voltage divided by resistance. But wait a minute, we gotta stop, because our voltage is not by itself, and it's not equal to anything right now. So to get it by itself, we are going to multiply our resistance to cancel it out on both sides. That cancels that resistance out, and that one cancels it out there. So now, all we are left for our formula is voltage is equal to current times our resistance, or Let's look at our problem and see what we have. Well, we have our current, because here it is, right here in amperes, 5.8. And we have our resistance, which is right here in ohms. So let's plug it into our formula. V is equal to 5.8 amperes multiplied by 2.3 ohms. After multiplying those out, you're going to get 13.34. Now we want to round to our nearest tenth here. So V is equal to 13.3. But can't forget units. This is in volts. Let's do one more of this type. All right. An ammeter in a simple circuit indicates 4.9 amperes. The circuit has a resistance of 2.5 ohms. What is the voltage in the circuit? Well, let's take a look. What are we looking for? We're looking for voltage. And what's our formula? Well, our formula for Ohm's law is current is equal to voltage over resistance. But we need to get to something that'll equal voltage. So we have to get V by itself. The opposite of division is multiplication. So we're going to multiply our R on both sides. Those R's cancel out, and we are left with V equals current times resistance. And now we can solve for voltage. What we know in our formula, what we know in our problem for our formula is our current is 4.9 amperes. We also know that our resistance is 2.5 ohms. So let's plug them into our formula. V is equal to 4.9 amperes multiplied by 2.5 ohms. After multiplying these two out, you get 12.25, and can't forget your units, volts. But we're not done yet. We gotta round. We're gonna round to our nearest tenth. V is equal to 12.3 volts. Now let's switch gears one more time, because now we've got to figure out how in the world to figure out resistance. A battery provides 12.0 volts to a circuit and 0.891 amperes of current flow through the circuit. What is the total resistance in the circuit? Well, let's look at what in the world we're looking for. We are looking for resistance. Now let's look at our formula. I, or current, is equal to voltage divided by resistance. Well, now wait a minute. This is confusing, because resistance is over here. We have to get resistance by itself. This one has an extra step. So to get resistance by itself, we have to do the opposite of what's going on down here. Now we can't just divide by the V, because if we divided by the V, we would have 1 over R. And that doesn't work. 1 over R is not a whole number. Okay? So, for our first step, we got to get R by itself. So what we're going to do to get R out of being a fraction is multiply R on both sides. Okay? So now, I'm just going to write this to make it a little more legible. We have V equals I times R. But we still want R by itself. So now we're going to divide by I to get it by itself. These two I's cancel out, and now we're just left with R. This is R equals voltage over current. This is the formula we're going to be using for this problem. So let's look at what we know. We know our voltage, which is right here, 12.0 volts. And we know our current, which is 0.891 amperes. Let's plug it in to our new formula. 12.0 volts over 0.891 amperes. Now when we calculate this out, you get R is equal to 13.46 ohms. But we're not done yet because we got to round this. So with the rounding, it'll be 13.5 ohms. And that is our answer. Let's look at another type of this problem. Okay. A battery provides 14.0 volts to a circuit and 0.971 amperes of current flow through the circuit. What is the total resistance in the circuit? Well, let's see what we're looking for. We're looking for resistance. But we know our formula from Ohm's law, which is current is equal to voltage over resistance. But we got to get resistance by itself. So the first step to get resistance by itself is by multiplying it to get it out of that fraction form. But what we do on one side, we have to do to the other. So right now we've got V equals I times R. We still need to get R by itself. So we're going to divide. Divide by I. These two cancel out. And we are just left with R is equal to V divided by I, or voltage divided by current. Now that we have our formula, let's look at what we have in our problem. We have our voltage right here, 14.0, and we have our amperes, 0.971 amperes, which is our current. So let's plug in to our formula. Our voltage is R equals 14.0 volts over 0.971 amperes. Calculating this all out, our resistance is equal to 14.41, and our units for this is ohms. But we're not done yet because we got to round. So our overall resistance is 14.4 ohms. Now let's do one more of this type. A battery provides 16.0 volts to a circuit and 1.341 amperes of current flow through the circuit. What is the total resistance in the circuit? Well, again, we're looking for resistance. Our formula from Ohm's law says that current is equal to voltage divided by resistance. But we need to get resistance by itself. So we have to multiply our resistance on both sides. These two cancel out, and we are left with voltage equals current times resistance. But we need to get resistance by itself. So we're going to divide by current on both sides. Those two cancel out, and we are left with resistance is equal to voltage divided by current. Now that we have our formula, let's look at our problem and see what we got. Our voltage is 16.0 volts. Our circuit is 1.341 amperes. And for this, now we're going to plug it all in. So resistance is equal to 16.0 volts over 1.341 amperes. Calculating this all out, our answer is going to be 11.93 ohms, but we got to round to the nearest tenth here, so our answer is 11.9 ohms.